it rises, the water level rises. Whenever it contracts, the water level falls. Other than that, if there is some leakage in the pipe, there may be some leakage in the pipe, there may be, though it is a closed water circuit, it is a closed water circuit, even then there may be some leakage in the pipe, there may be some evaporation, there may be such phenomena that water quantity may not be, maybe decreasing to some extent. In that case, we have an option of putting water down here, putting water, and we are supplying the closed system of piping. This is how we are doing this. This is how the expansion tank is working, and this is how we are doing the system. Here we have shown the legends. The legend shows every valve. You can see butterfly valve, you can see balancing valve, you can see check valve, you can see voice trainer. All the valves are indicated here. Legends show the types of valves. There is pressure gauge, there is temperature gauge. What these valves work differently is butterfly valve isolates the system. There is one butterfly valve here in case of pump, one butterfly valve here. I close the butterfly valve, then I take out the pump, I maintain it when I have to maintain it, put it back here, and again open the butterfly valve. So the water flows. Butterfly valve is an isolating valve. It isolates water flow from one part to another part. Then after butterfly valve comes balancing valve. Balancing valve is not an isolating valve. It regulates flow of water. You understand the regulation of flow of water? As the water flows continuously, we regulate the flow of water with the help of balancing valve. It increases or decreases the flow of water. So this is the balancing valve working here. This is the balancing valve working here, and through the balancing valve, the regulation taking place. This is, you can see, balancing valve. This is balancing valve. Water regulation is taking place in the chilled water system as a result of that. Now, other than the balancing valve, we have pressure gauge and temperature gauge. This is pressure gauge at the inlet and outlet of the pump, and pressure gauge and temperature gauge at the inlet and outlet of the chilling machine. In case of pump, we don't need temperature, we need pressure, because pump basically deals with water pressure. So, for that reason, in case of pump, we are putting pressure gauge. In case of chilling machine, we need both. What is the pressure drop to the chilling machine, and what is also the temperature drop to the chilling machine. So both can be measured by pressure and temperature gauge at the inlet and outlet. Then we have check valve. Check valve remains after the pump. The function of check valve is not to allow water come back to the pump. It's one way direction. This way it goes, but it doesn't return that way. Why? Because if pump is pumping this much water to different heights. Now it is, I am only showing here second up to second floor, but there may be water you are supplying to 80 floors, 90 floors in case of multi-storage building. The moment water, due to some reason, some system fails and water comes back through the check valve, there is no check valve, when water comes back to the pump was rotating in this direction, clockwise direction, it will suddenly start moving anti-clockwise and the whole pump will burst. Its veins will break, its casing pressure may come out, its casing may burst out, and as a result of that, there may be tremendous accident. To stop that, a check valve is provided after the pump. The check valve doesn't allow water to come back to the pump, it's a one-way direction valve only. Then it comes to butterfly valve, balancing valve, pressure gauge, temperature gauge to chilling machine, and then goes back, goes out and comes to the whole system. This is how the whole system is working. Now, there is another system we are putting into operation. This is HU, air handling unit. Air handling unit, the drawing is very congested, so we cannot show the valve arrangement here. I have shown it separately, the valve arrangement. In case of air handling unit, there is a cooling coil, you know that. There is a cooling coil, you know about that. There is a filter, you know about that. And there is a blower, you know about that. Here is the blower. This is what is air handling unit. In case of air handling unit, we are putting the water inside the chilled water coil, going through it, and air is passing over the coil. So air is getting heated up. Air is getting cooled. Water gets heated up, and hot water comes to the return pipe. That's what is happening in every HU. Now, in case of this HU, there is a butterfly valve, there is a waste strainer. Waste strainer is generally used to clean all the dirt particles or waste products in the system, because though it is a closed water system, there may be rusting in the pipe, there may be dust particles due to quality of water or little bad quality of water, and these dust particles should not enter the cooling coil, because dust particles go to the cooling coil, it produces the fouling in the cooling coil, and as a result of that, the resistance to heat transfer increases. To decrease the resistance of the heat transfer, we are generally providing with the waste strainer. Waste strainer takes out the dirt. We open this and take out the dirt outside. Waste strainer is available all in your houses also. You can see your drain pipeline. Waste strainers are there in the drain pipeline. They just put this, they open the screws and take out the drains, the materials out, and then again put it back. This is how the waste strainer works. And this is how the system works. Now, this is all about chilled water system, what I am talking about in summer system, that is cooling. Now, there is another system that is heating in winter. Other than cooling, there is heating in winter. Chilled water system will do the cooling in case of HU. In case of these same pipes, if I supply hot water in the winter season, the same cold air through the HU will pass through the hot water, will get heated and will supply to the system. System means the room. Hot air will be supplied to the room. Now, in Western countries, they have separate piping for chilled water system and condensed water and hot water system. But in our country like India, where money is a big problem, the client generally doesn't want that. The client wants there should be the same pipeline used, so that piping cost is saved, and a boiler can be put in the system. That we have done. We have put a parallel pumping and a boiler here. Now you can see this. The boiler has got an arrangement of butterfly valve, balancing valve, and then pressure gauge, temperature gauge, pressure gauge, temperature gauge. Before that, there is a pump. This pump is separated by this butterfly valve at the top. This is the butterfly valve we are putting on during winter. This is the butterfly valve we are putting on during summer. So you can understand. During summer, I'll open this valve, I'll close this valve. During winter, I will open this valve and close this valve. So what will happen? During winter, water won't pass through the chilled water pipeline. It will come to the hot water pipeline and goes to boiler. Boiler increases this temperature from here to here. This temperature increment comes here and goes there and supplies to different HUs and XUs. This is what boiler is doing, the hot water piping system. The same piping I am using for chilled water as well as hot water. Try to understand this whole phenomenon. This is very important. I am supplying both chilled water and hot water to the system. The same pipeline I am using for chilled water, hot water in the system, with a change in the plant room. In the plant room, we are putting chilling machines and then separate boiler. All are in parallel lines. During summer, again I am repeating, during summer, I put this valve on, put this valve off. So the on valve, water will pass through the chilled water system during summer. During winter, I close this valve, open this valve. Water will come back, come here, pass through this pipeline, pass to boiler, and in the boiler, there is a rise in temperature of delta T here, and through there, water will pass through that system. The rise in temperature depends on boiler to boiler manufacturer, as per specification given by you. Now, this is one of the hot water system we are using. But in case of our countries, sometimes instead of hot water system, people use strip heaters. Strip heaters are the systems where heaters are generally supplied by electric current and heaters get on. These heaters are placed in the HU duct. That HU blower is coming, that is passed through duct. That duct is put in the strip heaters, and that heats up. So in that case, you don't need a boiler, don't need a hot water system. But this is not good for health. Nowadays, the building services authority are not permitting the strip heaters in general cases, because strip heaters leave small strips of materials or metals when it becomes old. These metals come to the building, you inhale with your respiratory system gets affected, it's bad for health. So we are generally using nowadays the boiler system and the alternate system. Again I am telling, in Western countries this hot water system is totally separate. But there are two problems with the separate hot water system and chilled water system. We put it separately. The problems are, number one, space. Hot water system will take a lot of space. Chilled water system will take a lot of space. And we don't have a space. In place like Nehru Place, you can go, this is a typical example in Delhi, where it is very congested. You cannot put both the pipes together. This is one problem. And number two, at putting a total hot water pipeline doubles the cost of piping, because you are putting chilled water pipeline here and then you are putting hot water pipeline here. It doubles your costing. This is what you have to see. This is how the whole chilled water piping and hot water piping system is working in this diagram. I hope the class is clear to you. If there is any problem, you all know my phone number. It is available in the WhatsApp. You can always ask me over phone and I will answer you all the questions. This is chilled water system in case of multi-floor buildings, and this system we are using in HVAC. This is the basic system. Now there are many other value additions to this, like we can put VFD, that is variable frequency drive, in the pump. This variable frequency drive actually controls the speed of pump. How it controls the speed of pump? It takes the overall temperature reading here. Depending on the temperature reading, high or low, accordingly it modulates the pump speed. And as it modulates the pump speed, at a low speed, the lesser power is required to run the pump, and you save in power. But these are value additions. You need not know these at this point of time, but you should know about VFDs. VFDs is variable frequency drive used in the pumps. These variable frequency drives moves the pump. Now this same concept is being used in inverter air conditioner you use in your house. You know, split ACs are coming as inverter air conditioners nowadays in your house. In the inverter air conditioners, you are having compressor, which depending on the room load controls the compressor speed. If the compressor speed decreases, the power consumption decreases. If the compressor speed increases, the power consumption increases. Now how does it modulate? It modulates like in summer, at the time of what load is there, room load is there, at time of 6 p.m. in the evening, the load is much less at 12 in the night. So what happens? The compressor modulates its speed accordingly and the power consumption decreases. So what happens? While you are paying 2000 to 2500 in case of general air conditioners, you are paying only 1000, half of that in case of inverter air conditioners. The same principle is being basically used here in chilled water pump system or hot water pump system. We modulate the pump speed along with the temperature and control it accordingly. These are all about your chilled water and hot water pumps. I think the whole picture is clear to you and you are able to understand. We have to resort to online teaching for present. You know the condition of the country. It's deteriorating, but there are hopes also. Let us see. By that time, we have to do the online classes. I am taking first time online classes, so there may be some shortfalls in the classes, but we have to bear with that, and I will improve with time. Okay, dear students, thank you for the class.